All right, so guys, I hope you understand what I'm saying. So the first line, let me look at this line here. Space is subdivided into regular grids of square grid cells. So this one is English language right here. Space. So your target area, your project area, is divided into regular grids of square grid cells. And this is a question that I've asked in exam before, and I was shocked that people couldn't figure out what I was talking about. Okay? So before a picture is taken, put it in your mind. All these selfies that people are taking, when you do that, and then the camera is pointing on you, when you take the phone and you actually do that, okay, it's dividing you into squares. People should know this. And if you've actually seen artists drawing a picture, a real picture before, okay, so I'm taking a selfie right now, something we all do a lot. So once I take it, that's it. It's divided me into millions of squares. And in those millions of squares, how does it do it? It's from the phone. The phone already has this grid, are you okay, or squares in there already. It's a screen. And the size of those squares determine the resolution. The resolution. And resolution is like the accuracy. So people buy phones and then they actually look out for one number. The number is megapixels. Megapixels. So the megapixel, the pixel is the square, those small squares that make up the picture. And pixel actually is an annotation for picture elements. It stands for picture elements. Pixel is picture elements. Okay, so if you asked how the raster data structure, the first thing that should come to your mind is that space is subdivided into regular grids of square grid cells. You see, it's not regular grid cells, regular grids of square grid cells. So the squares are now the cells. Are you okay? All right, hold on, let me see. Okay, so the raster model is with us. The raster data structure is with us. We see it, but we don't. Wait, what's happening? There's a delay. Can you guys hear me? I think there's a delay. I don't know where it came from. Is it gone? All right, so the raster data structure, the first line to understand is this one. Space subdivided into regular grids of square grid cells. So I'm going to focus on this one. Okay, I'm going to focus on this one. All right, so if a satellite is in the sky and it takes an imagery or produces an imagery of 30-meter resolution, then what do you think that means? What does that statement mean? What does that statement mean? So you have to listen to me because my lecture is always interactive. If you don't listen to me, when I ask a question and I ask me, say, what did you say? Most of you are cooking when we are teaching you online, isn't it?
It means that the camera has divided into
your network, oh, Benjamin, your network is a bad one.
I don't say.
Come to campus and stop staying at home being online.
It's raining
It's raining.
Over here.
Oh, okay.
It's
I hope.
raining over here.
Okay.
That's why.
Can you type your answer in the chat? I'll read it for them to hear. Type your answer in the chat. Type your answer in the chat for you. Okay, so Ben is going to come back with us. He's going to type something to the chat so that we know what he was trying to submit. But that's the raster data structure for you. Are you okay? Think about it like a picture that you are taking. When you take a picture, it depends on the resolution of the camera or the sensor. So cameras are sensors, put it in your mind. Cameras are what? Sensors. And for these phones, there are so many sensors in there. We have magnetometer, we have accelerometer, we have camera, we have other sensors, okay, that are built into it. That's why they're expensive. And now every Tom, Dick, and Harry, you want to have an expensive phone like that. They don't even know what is in there. And they are just making calls with it, okay? It's got a lot more than your laptop does. Your phone probably has more things than your laptop does. Okay. So other forms of, okay, so let me read Ben's answer. He says, it means that the image has been divided into 30 square grids. Okay, Ben, that is incorrect. If you can hear me, I know your network is delayed. Okay, rather, the answer should be that every square grid has a dimension. Okay, try. Let's listen to you. Yeah. Let's hear you. You should have put up your hand so that I know who is talking, but you don't want to obey my rules. So carry on. Yes. The answer should be open. Oh, I'm listening to you. Oh, I'm listening to you. Someone said the answer should be open. What does it mean by that? The answer should be open. It doesn't make sense to me. Okay, you sent it to only me. You didn't send it to everyone. And is that the case? All right. Someone wanted to answer. I'm waiting for you to answer. That's why I've gone quiet. Yes. Okay, let me paste Ben's answer because I think apparently he didn't see it. To everyone in the meeting, okay, so I'm waiting for whoever wanted to contribute. Okay, since you're not saying anything, then I'll go ahead and tell you what it is. Okay, so 30-meter resolution. I'm trying to type it at the same time. Resolution means every square in the imagery represents 30 meter by 30 meter square on the ground. Okay, what does it mean? It means this is 30 times 30 is what? What's 30 times 30? 9,000 or something like that, right? Okay, it's not good to use calculator. So 9,000 square meters.
It's 900.
Exactly, 900 square meters. 30 times 30. 900 square meters. Are we good? So 900 square meters, of course, you can convert it to maybe kilometers to appreciate it. So that is what every square you are seeing in the image represents. And it means that within that square, there's just one color of representation. It's the smallest, because the pixel is the smallest representation in an image. All right. So that is that. The location of each cell, also other forms of polygonal meshes known as picture elements, okay, do exist. We can have that. It's possible that you don't use, squares, probably you think about that. Shapes as well. The location of each cell is defined by its row and column numbers. All right. So you can imagine you have squares arranged in rows and columns, a lot of it, like what we are looking at now. Okay. In that case, then if you want to find a particular cell, you just say column number 1, row number 2, that kind of thing. And it tells you the location of each cell. Okay. So let me just demonstrate this to you. So it looks like something like this. So the intersection, so you have squares, right? These are squares. This is the pixel. Okay. But the pixel is actually defined by this column and that row. So this is the row. Everything here, okay, is the row. And everything here is the column. Okay. Okay, so now, if there is a river or a road, let's go for a road. If there's a road, and then you've divided the space into gray squares, it's going to record the object to the nearest pixel. So this whole thing, this whole cell will record that there's a root. Are you okay? Either in terms of color or whatever. Okay. Then the same is going to happen for the next cell. It's going to record one color value that can be looked up and mapped as a road. Are you okay? So if you don't have a good resolution sensor, are you okay, or camera, then your image is always going to look funny. So have you seen someone with a phone which is of low low specifications? When they take a picture, they don't like it. So they always come to you and ask for your phone. Are you okay? And then they'll say, oh, can I use your phone to take a picture? People do that because the resolution of their phones are not good. And the pixels are not many. In other words, the megapixel is not many. Not many megapixels. Normally you see this. So someone buys a phone which is 12 megapixels. What it means is that he has 12 million pixels. 12 million pixels. Can you imagine 12 million pixels on one small phone like that? That is why your image is sharp. That's why someone takes a picture, you're like, wow, I love it. Are you okay? Another person takes a picture, you're like, oh, okay. See about that. Let's talk about it later. Okay, so that is the analogy to the raster data structure. The pixels and your coordinates and your position are inferred by the row and column, okay, numbers. In other words, we have every pixel being defined like this. So 1, 2, 3, 4. Okay, you can also number this one 1, 2, 3. So if you want to refer to a particular pixel, then you just say, you read the column and row and column, that's 2, 4, like a matrix. So the raster data structure looks more like a matrix. Okay. All right. Now remember that we are recording the attributes, something that is on the ground. Okay. So when you take a picture and there's a pimple or something on your face, it records it. Okay. That is recorded into the imagery. All right. So Also, you can have different themes and layers. Are you okay? You can have different themes and layers. All right. Yep, there's a need for a lookup table to tell you what the colors represent. If it's a true color image, if you're just taking a photograph of an area so that we can see the beauty of it and just see it as it is, then in that case, excuse me, you don't need a lookup table. But there are times where you are trying to interpret, do an interpretation, an analysis of the data. You may want to, find a way to map it and say that when you see this color represents this particular attribute. Okay, in this case, 1 represents forest, okay, and then 2 represents cultivated field, and then 3 represents water body, and then 4 represents bare rock. Is all right. So we can now, the image is now classified. In fact, we come into classification. That we are not there in this class. I'm not even going to talk about that, but that is what really happens when we actually take a picture or when we deal with raster data model or raster data structure. Okay. So the area that each cell represents defines the spatial resolution of the data. I think I've talked about that. And so if you have any question, you can let me have it. But I think I've touched on spatial resolution. I've talked about resolution. And so the 30-meter satellite imagery, for example, you get it. We are having 900 square meters being the size of that. So that 30-meter is the resolution. All right. Great. The bigger it is, you don't like that, it shouldn't be appropriate for any application. All right, the position of each geographic feature is only recorded to the nearest pixel. I think we've talked about that. The value stored for each cell indicates the types of objects. I think we've talked about that already. We can store different types of values. Normally, you see, when we are recording, we can record 1, 2, 3, 4. We can record color values. You can record, but normally we make use of the integer values. Is that okay? To represent the values in the cell, all right? An attribute. Wait, carrying on. How did we get here? Come on, go back. All right, so here we are. Separate themes, I think we talked about it. The same idea of layers and themes, it applies in raster and in vector. All right, we can also, instead of using regular grids or square grid cells, we can actually use irregular tessellations. So the word tessellation is like covering something. To tessellate, to cover something. So we can talk about an irregular tessellation, like what we call the triangulated irregular network, also known as a tin. So the tin is very big. That's why you are looking on the right-hand side. Okay. This is used, I've seen this in cartoons because I like games and things like that before. I've always loved games. In fact, I really want to develop a game this year. But you can see that this is representing a surface, isn't it? This looks more like, you're going to, some countryside area and you're walking over it. I mean, if you saw this in a game, you'll be okay, won't you? All right. So, but that surface has been created with triangles only. Are you okay? And then the faces of the triangle have been given a value based on the interpolation. But please, let's not go to all that. I want you to just understand the basic, that you don't have to use squares. You can use triangles. In that case, then you have the triangular irregular network. Okay. Enough on that. Let's talk about the vector. I think I already talked about the points, lines, polygons. We all know points, lines, polygons. That's it on the board. These are points, okay? These are lines. Okay, so we have points, we have polygons, we have, what's happening here? Okay, let me get my Okay, so there's a point, set of points joined together by lines. You have polygons. Are you okay? And then even these are also polygons. Okay, forming regions. All right. In a computer, you store points in the tabular form, point number, and an XY. We need that XY for us to have, the whole thing, locational thing working for us. Then we can now add attributes to it. Is that okay? All right. So we have this table to explain that. We can also do the same for a line. We can store a line. Remember, we talked about topology, and then the line is also known as an arc. A better word for a line would be an arc. And then the beginning and end node of a line, an arc, is called node. So we can store the nodes. Okay, so every line can be defined as by the first and last nodes, and then we can store the nodes with their coordinates. So lines are made up of points, and then polygons are made up of lines. Okay. So here you can see the polygons on the right hand side have been stored in the table by the arc numbers. Okay. So I think there are more on this. Some of the things I want you to ignore: spaghetti and hierarchical vector model. I don't want to bore you with all that. You don't need that. Okay, so yeah, I think talk about this. So topology is relevant to the vector data model. So you can't do topology. The topological concepts we talked about, topological rules, topology, only applies to vector and not raster. It's like nobody mixes the two. We don't do that. Okay, great. Right, I think we have the advantages and disadvantages here. Okay, so before we come to it, can anybody start? What are some of the advantages? If you're asked to represent an object by raster or vector, which one would you go for and why? Question? Someone is asking a question, like in Excel. Texting is saying, like, what will happen? Yes, rows and columns like in Excel. So you can use, if I want to even describe the raster model or ask design a question on my computer for you to represent raster, I always go to Excel. So you are right, Ben. Yeah. Excel, the spreadsheet looks just like raster. Very good. I'm happy someone is following. All right. Which one would you go for? Raster or vector for representing an object on the ground? Okay, did I jump something here? I didn't know. I'm jumping over some of the things. So those who are not here. All right. Yeah, I think all these things are, yeah, they didn't talk about. Ignore the spaghetti hierarchical bit. Okay. Yeah. So here, if you want to understand what I've talked about, here we are trying to represent a field. Okay, some parts of it is corn, some part of it is wheat. Let's continue, guys. So what we've seen on the board is two different ways of representing objects on the ground. In this case, a field of maybe corn, wheat, bare soil, okay, green, lush vegetation. Let me put it that way. Okay. So you can see that in the left one and the right one of them is raster, the other is vector. So you can see that the left one is the vector, the right one is the raster, because the right one is dividing the area into squares and it's trying to now give a value to every cell. So this is the best explanation of what vector is and what raster is. Okay? Yeah. Let's move on. So if you have an answer for my question, you can bring it up. Otherwise, I'll move on because I do get bored. Yeah, vector features. Okay. So vector can be used to store like things like location, things like a location, things that are discrete, are you okay, as opposed to continuous. So discrete means that it ends here, like a regional boundary, things like that, constituency boundaries, things that you can actually define them. That there it is, bang, football field, it begins and ends here. That kind of thing. That's discrete. And then continuous data. Example of continuous data will be something like temperature. Everywhere you go, the temperature is there. There's some temperature there. It's different. It may not be, and then, but everywhere you go, there's some temperature that you can measure. Okay, so that is continuous data. All right. So. How many hours have we done? We started 1:30, isn't it? 1:30, 2:30, 3:30. Okay, so we're going to, my time is not correct. Okay, so we should be getting ready. We have like 30 minutes to finish. Okay, so let me fill you. If you have an answer for my question, you can let me have it. Otherwise, like I always say, I always have a question for you to answer for me at the end of it. All right, so raster data models, yes. I think we checked out most of it. I'm just going through what you are seeing on the board. Topology is a relevant concept of tessellated structures. Yeah, you can use topology on raster models. Okay. Meanwhile, look at this statement. Since adjacency and connectivity are implicit in the location of a particular cell in the data matrix. So what the next cell, we can always tell what the next cell is, but you can't do a lot of analysis with the raster data. Okay, but then topologically correct network data, road data can be used for routing, okay, for routing, so that you can tell that the shortest path is here, things like that. We are going to talk about the shortest path also in this class. I don't like how this thing moves. Okay. All right, so vector data, we are going to end the whole today's lecture with the advantages and disadvantages of vector and then raster data. So data can be represented at its original, have I resumed? Pause, okay, yeah, I've resumed. Data can be represented at its original resolution and form without generalization. So that is an advantage. Okay, you don't have to generalize when it comes to vector data sets. Okay, but then also one thing we should know is that we are always sampling. There are millions of points that can be collected potentially, that we can actually collect. But our geography is so complex that there's so much you can, within any project area, you miss something. Okay, you have to do some, leave some, pick some. So there's this kind of sampling happening with the complex nature of the data that is available. All right, we have 10 minutes when it ends. If we're not ended the lecture, we come back again, because we are finishing in a couple of minutes time, maybe 10 to 20 minutes we are done. Yeah, so one advantage of the vector data is that its graphic output is usually more aesthetically pleasing. But I keep saying that is subjective. Is that okay? Aesthetically pleasing means that it's beautiful. I mean, if you want to just say it in a layman's terms. And so I'm going to just show you, maybe I'm just going to show you Google Map, and then we are going to switch on the satellite layer, and I'm going to switch on the vector, so the raster layer and then the vector layer. Hey, there's a lot of noise here all of a sudden. I don't know where it's coming from. Am I safe? Anyway, so I'm going to share my screen. You're going to see vector. So what we are seeing now is a vector data structure. This is vector. What you are seeing on the board is vector with some annotations and symbols. Okay. So you can see we have that we can remove the text. The red code, North, Legon, Medina, Zuma. We can remove all that. This is where that's why it's coming up. So this is vector. what we just read as an advantage for vector is that vector is aesthetically pleasing, it's beautiful compared to the raster counterpart. So let's look at raster. It's coming up. It's taking a while. My network is a bit slow all of a sudden. But here we are having an overlay of vector and raster. So let's put that in our mind that we are still seeing the vector, but then the raster is beneath it. Is that okay? All right. So the question is that which one is more nicer, to see the satellite imagery or to see the vector image, the raster or the vector? So this is raster. Satellite image is raster, and then this one is vector. Are you okay? It's subject. It depends on the resolution. I mean, for me, that is what I think. Is that okay? That's my opinion. But per the notes I'm giving you, the vector is supposed to have a better graphic output. Is that okay? All right. Now the vector is accurate in representation. Okay, so that is why surveyors are picking, they are using GPS and all these things. What they are getting is points, and then later they can join the points. And we are saying that is more accurate. Are you okay? The geographic location of the data is maintained. Are you okay? All right. Also, you need to convert. So that's an advantage in a way. Most data exists as what? Vector. Okay. Most data exists as vector. So you don't need to do any conversion. You just use it as it is. We can also encode topology. Remember what topology is? Topology is a relationship between geographic features. We can encode topology in vector. So we consider that as an advantage. All right, so the location of each vertex needs to be stored explicitly. That's it. So we are talking about disadvantages. You have to be storing every vertex explicitly. So that's a disadvantage. For effective analysis, vector data must be converted into topological structure for effective analysis. So if it's, you can have vector data, but it may not be topologically correct, or it may not have a topological structure. So in that case, you need to now go through the process of correcting for the overshoots and the undershoots and overshoots. All right, and build topology. There's something called build topology. You can do it in GIS software. All right.